third period, I think I'm not fourth period, then fifth period, I have my anatomy practical, and then
All right, let's take a look at page 388. Yesterday we were practicing trying to figure out where an angle is located, okay, based on some trig values, like is it in a quadrant or does an angle land on an axis? And we also practiced yesterday finding trig values, okay, like the sine value, cosine value, tangent value, and then their reciprocals. We're going to do more of that today, so it's just going to be a continuation, more practice from yesterday. The questions, though, are going to be a little less straightforward, perhaps, because if we take a look at the two at the top that we did yesterday, they were nice and gave us the actual point where the angle kind of went through on a graph or a coordinate system. They might not do that today. That doesn't mean we can't figure it out. It just means that we have a different piece of information to analyze. So it's still going to be the same concepts from yesterday, just not perhaps as straightforward with the directions. So let's see if we can tackle these. So suppose that the sine value of an angle alpha is -3/5, and the tangent value of that same angle is less than 0, okay, meaning negative. We're going to see if we can answer these following questions. Can we determine where that angle alpha might land? Quadrant 1, quadrant 2, quadrant 3, does it land on an axis? Okay, let's go ahead and decipher these two different pieces that they give us at the top. Notice how they tell us the sine value of that angle is -3/5. What variable does sine represent again on our unit circle? You got a 50-50 shot.
Good morning.
Good morning. Anything for the office today? I think we're good. Thank you. Yep. Yeah. Sine's the y value. All right, so notice how if the sine ratio is negative, that means our y value must be negative as well. All right, so if you think about a coordinate system, where do we have a y value that's negative? Can we narrow it down to a quadrant or two? Yeah?
It would be 3 and 4.
3 and 4. All right, so we're somewhere down here. Let's go ahead and use the next piece. We need the tangent value of that angle to be negative. What's our tangent relationship between x and y on our unit circle? Yeah.
It's also negative.
All right, so we know it's negative. What is tangent representing a y coordinate, an x coordinate, both coordinates? Y over x. Okay, so we need this fraction to also be negative. If a fraction is negative, that means either the top or the bottom is negative. You can't have both. So can we determine whether the y is negative or the x is negative? Yeah.
Well, what if the x has to be positive, the y is negative?
There we go. Okay, so from the previous one, we said the y is already negative. Okay, y is already negative. So x must be positive. So let's use that piece of information to help us narrow it down even further. Okay, we already said we might be in quadrant 3 or 4 based off the concept that the y had to be negative. Now that we know the x has to be positive between the two quadrants, which one is the angle in? Yeah, quadrant 4. All right, so we'll say alpha is in quadrant 4. So now that we know where an angle lands, we're going to go ahead and try to draw that reference triangle from yesterday, a triangle that touches the x-axis, and we're going to find the other 5 trig ratios. We already know what the sine ratio is. Somehow we should be able to figure out the other 6. So we know that our angle is in quadrant 4. Let's go ahead and draw quadrant 4. and our angle goes through quadrant 4. We're going to use that angle to create a reference triangle, a triangle that touches the x-axis. So we'll go ahead and draw a leg on the x-axis and another leg that connects our angle. So if you wanted to draw in angle alpha, that would be your reference angle. Who are we looking for? Right? Now, in order for us to figure out the other 5 trig values, we need to somehow label the sides of that triangle like we did yesterday, and we can analyze the SOHCAHTOA relationships to help us figure out the other values. Somehow, though, maybe we can use the sine ratio to help us fill out some of these sides. What does sine represent again for our SOHCAHTOA relationship? Which sides should we know? Good, Marie? Okay, so on the unit circle, sine represents a y coordinate, okay? But sine also represents, in terms of SOHCAHTOA, which sides of a right triangle? Yeah. Opposite over hypotenuse. So notice how this -3 is your opposite side, and the 5 is your hypotenuse. All right, so I don't want us to get too confused because we have all these connections and relationships between unit circle and trig values and SOHCAHTOA. Okay, sine does represent a y coordinate on the unit circle, but sine also represents opposite over hypotenuse in terms of a right triangle. So if this is where our reference angle alpha is, we should be able to label the opposite side as -3 and the hypotenuse as 5. Yeah. Great question. Can you say it a little bit louder so everyone can hear it? How do you know the 3 is negative? Okay, because in a fraction, we know that the top can be negative or the bottom, right? Okay, so here's the deal. The hypotenuse is never ever going to be negative because that's where your angle is pointing to, or that's the path that the angle falls, or where it lands. So the only negative values you can have are the legs. So either the x-axis leg or that up and down leg. Great question. Okay, the hypotenuse is never negative. You might want to write that down. Okay, so just like yesterday, we're starting to have this reference triangle be formed. Let's go ahead and try to figure out this missing side, because if we're going to go through all of the SOHCAHTOA relationships, we need to know the opposite side, the adjacent side, and the hypotenuse to figure all those out. So how can we figure out that missing side? Yeah. Pythagorean theorem. All right, so we don't know what that x side is. You can label it a or x, whatever variable. So we need x squared plus -3 squared, and that would equal our hypotenuse squared. So x squared plus 9 equals 25. X squared equals 16. Square root of 16 is 4. All right, so we have all 3 sides filled out. We should now be able to figure out the other trig ratios. So the sine of our angle alpha was already given to us. Let's go ahead and try the cosine value and the tangent value. On the unit circle, I know cosine represents an x value, but we are not dealing with a unit circle right now. We're dealing with a reference triangle. So we're going to have to utilize the SOHCAHTOA relationships. What would our cosine ratio look like? We have our angle alpha right here. Can we figure out the cosine ratio? What's the adjacent side over the hypotenuse? Yeah? 4/5. Good. All right. And then what about our tangent ratio? Think about SOHCAHTOA. Yeah? -3/4. Perfect. All right. So we know sine, cosine, and tangent. Let's go ahead now and talk about their reciprocals. Cosecant secant, and cotangent. So we got to just flip or reciprocate these values. Cosecant is the reciprocal of sine. So if we flip the sine numbers, we'll have -5/3. Secant we have is the reciprocal of cosine. So if we flip the cosine ratio, we get 5/4. And cotangent, reciprocal of tangent, we'll flip the tangent fraction. Remember doing that from yesterday? Okay, it was just a little bit different today because they didn't give us the ordered pair. Okay, they just particularly gave us a trig ratio, and off that trig ratio, we could figure out what that reference triangle looked like, utilizing those SOHCAHTOA relationships. So it's a very similar type of question or problem, just you're not starting with the same piece of information. All right, let's try some more. We're going to do a bunch of these today. Suppose that the secant value is -3/2 and that tangent is greater than 0. Use this information to help you answer the following questions. All right, so which quadrant might this angle theta be located in? Let's check out our first piece. How is secant related to either x or y on the unit circle? Secant's one of our reciprocal ones, yeah. 1/y. All right, so if the secant value is -3/2, that must mean our y value is negative. The 1 can't be negative because that represents our radius kind of on the unit circle. All right, so the y value must be negative. All right, think about a coordinate system. Where is y negative? Yeah. Do you know what? It is. I got it mixed up. And normally everyone does this, and I still fall for it sometimes because it starts with an S and I think it's sine, right? But it's actually cosine. Good catch. So this means x is negative. That's going to change some things. Where's x negative? Yeah. Second and third. All right, so we're somewhere over there. Let's check out tangent. Tangent is our y/x relationship on the unit circle using those coordinates. We want tangent to be positive. Yes? All right, so if we already know x is negative, all right, x is already negative. And in order for this fraction to be positive, that means the y value must be negative as well. And negative divided by negative would give you a positive. So y is negative also. So if we have a negative x and a negative y, which quadrant are we located in? Yeah, there we go. So we'll say theta is in quadrant 3. Let's go ahead and draw that angle in quadrant 3. We don't know what the angle is, we just know we're in quadrant 3 somewhere. And with that angle in quadrant 3, we will form a reference triangle, a triangle that touches the x-axis. And we should be able to figure out the other 5 trig ratios. And we already know what the secant is, so we can utilize that to help us find the other ones. So the question is, if secant is -3/2, what side can we label as -3, and what side can we label as 2? Or maybe I'll do this. We'll do the negative out front. What do you think? Yeah. There we go. All right, so if secant is the reciprocal of cosine, instead of being adjacent over hypotenuse, like what cosine is, it'd be hypotenuse over adjacent. Now, the hypotenuse is never negative. Okay, that brings in Tori's question from before. So this would have to be a +3, which means the adjacent side is -2. And I hope that makes sense, because isn't the top of that triangle drawn on the negative x-axis? it should have a negative value. All right, let's see if we can figure out that missing side utilizing the Pythagorean theorem. So we'll have negative 2 squared plus b squared equals 3 squared. Looks like we get the square root of 5. Now here's what's a little tricky. Whenever you take the square root of both sides, hopefully we realize we should put in a plus or a minus, right? Should this be a positive square root or a negative square root? How can you tell? Yeah. How'd you know? Yeah. Y is negative. If we are in the third quadrant, we need a y value that's negative, but also an x value. Okay, that's what we mentioned here at the top. So even though it's a square root of 5 value, we got to make sure we're aware that it should be negative for this particular example because we're in the third quadrant. So now that we have all 3 sides labeled, let's go ahead and figure out the other trig relationships. We already have secant. Maybe we'll try cosine because that would just be the reciprocal of secant. So if we flipped that fraction, we would have negative 2 over 3. Let's go ahead and try the sine relationship. So using our angle theta, we got to figure out the opposite side over the hypotenuse. That'd be negative square root of 5 over 3. For cosecant, we can just flip that value. But notice how that puts a square root in the denominator. So we can get rid of it. Multiply square root of 5 up top, square root of 5 down below. We'd have negative 3 square root of 5 over 5. Let's see, our last set would be the tangents. Tangent, think about SOHCAHTOA, we need opposite, which would be a negative square root of 5 over the adjacent, which would be negative 2. They're both negative, so that would cancel out and make it a positive. And lastly, for cotangent, if we reciprocate that fraction, we'll get a square root in the denominator, but we can get rid of it. Multiply up top and down below. 2 square root of 5 over 5. Are we doing okay? I feel like we're going really fast, but that doesn't necessarily mean that's a bad thing. It just means we're that good. Too fast, too slow, just right? Good. I feel like I'm Goldilocks. Too hot, too cold, just right? All right. I'll leave that one up there. We'll go ahead and try the next one. Suppose that cosecant of alpha is 7 over 3, and cotangent of alpha is negative. Okay, less than 0. Again, use the information to figure out where this angle is located. How is cosecant related to x or y on the unit circle? Yeah. 1 over y. All right, so notice how a cosecant has a positive value, okay, 7 over 3. So in this case, y must be positive. Can we narrow it down into which quadrant we might be in? Yeah? 1 or 2. Good. Let's use the next piece to narrow it down even further. How is cotangent related to x and y on the unit circle? Yeah?
It's also adjacent. So, or adjacent over opposite.
Adjacent over opposite, yep. So if it's the reciprocal of tangent, yeah?
It's less than 0 though, so that would make x like.
All right, so we would have x over y. If tangent is normally y over x, cotangent would be x over y. And we know that this fraction must be negative. So in order for a fraction to be negative, either the top or the bottom have to be negative. We already know y is positive. So that must mean x is negative. So between quadrants 1 and 2, where do we have a positive y but a negative x? Yeah. There we go. All right, so alpha is in quadrant 2. Let's go ahead and draw quadrant 2 and an angle that goes through that quadrant. We're going to create a reference triangle with that angle. Okay, a triangle that touches the x-axis. We can label our reference angle alpha. And somehow, we should be able to use this cosecant ratio of 7/3 to help us label some of the sides. So what might the 7 represent? What might the 3 represent? If cosecant is the reciprocal of sine. Yeah? There we go. Hypotenuse over opposite. So if alpha is that reference angle, okay, that touches the x-axis, the hypotenuse would be 7. Opposite would be 3. Once we know 2 sides, we should be able to figure out the third, okay, using the Pythagorean theorem. Looks like we get the square root of 40. Does that need to be positive or negative? Yeah. It would be negative. All right, so negative square root of 40. If you feel like rationalizing the square root of 40, like taking out a perfect square, you could do that. I'm not going to make you do that. So if you want to leave it the square root of 40, that's fine. Bless you. All right, but if you did want to rationalize it, it would be 2 square roots of 10. Okay, up to you. So now that we have all 3 sides filled out, let's go ahead and try to find the other trig ratios. Do you guys want to try to do that? See how you do? All right, you already know cosecant, so you have 5 more to tackle. Bless you. Oops, sorry. All right, any takers on sine? We already know cosecant. Yeah. 3/7. We'll flip cosecant. Perfect. What about cosine? Can we use our SOHCAHTOA relationship, good, Marie?
Negative square root of 40 over 7.
over 7. All right, so we have the adjacent side over the hypotenuse. Perfect. If that's what cosine is, can we figure out secant? Yeah.
Negative 7 square root of 40 over 40.
Okay, so initially you'd have negative 7 over the square root of 40. We have a square root in the denominator, so we can multiply that square root on top and bottom to get rid of it. In the end, negative 7 square root of 40 over 40. How are we doing so far? Pretty good. All right. Last set. What about tangent? Think about SOHCAHTOA. Yeah? Okay, so initially we would have the opposite side over the adjacent. So that'd be negative 3 over square root of 40. Squared in the denominator, we can get rid of it. So negative 3 square root of 40 over 40. Love it. And last but not least, cotangent. If we were to flip our value from tangent, what would it look like? You can either flip the final one or the initial one. Either way, they should simplify to the same thing. Maybe the initial one would be a little bit easier. Okay, we'd have negative square root of 40 over 3 because the square root's no longer in the denominator. How'd you guys do? So far? Pretty good? All right, let's go ahead and try another one. The terminal side, meaning the ending side of an angle beta, okay, letter B there, lies in quadrant 2. Maybe we'll go ahead and draw quadrant 2. This time they're telling us, though, the angle lies along the line 2x plus 5 equals 0. Okay, so a different beginning piece of information. Initially, they gave us a point. Okay, that was yesterday. What we've been doing so far is they gave us a trig value, and we use that to help us figure out our reference triangle. Somehow, they're giving us a line now, and we should be able to figure out some other trig values, like sine, tangent, cosecant, whatever we want to figure out. All right, how about we try to draw this line in quadrant 2? That way we can see where this angle is actually located. How might you want to graph 2x plus 5 equals 0? How do you graph a line? Yeah?
Well, you can solve for y.
There you go. Let's make it look like y equals mx plus b. That's been like beaten into your brain since Algebra 1. Okay, y equals mx plus b, slope-intercept form. So we'll get the y by itself. That means we can subtract the 2x over. And then we can divide the 5. So we'll have negative 2/5 x. Now if we're actually going to graph this line, throwing in some tick marks might be useful. What's the y-intercept of our line? What's that b value on the end? 0, right? You could put plus 0 there if you wanted to. So that means we go through the origin. Just like all of the other reference triangles we drew went through the origin. And let's go ahead and use the slope to help us figure out another point. So the slope, negative 2 over 5, if we go down 2 over 5, notice how we would land in the 4th quadrant, right? But we want to be in the 2nd. So what's another way we can use that slope to make sure we land somewhere up here? Yeah?
Up to over 5.
We could reverse the slope. So instead of going down to the right, we could go up and to the left. So if we go up 2 over 5, we'll land somewhere right there. So if we were to connect, just like any other line you would draw, the y-intercept with that slope point, that's what your angle looks like. Your angle is landing on that line. So let's go ahead and form a reference triangle with that angle. It would touch the x-axis, and I think we're good to go. Can we label any of the sides of that triangle? What do you think, Rebecca?
Well, the adjacent side with theta would be 5, and then the opposite would be 2.
All right, so the adjacent side, this distance here, have to be negative 5, okay, but it's definitely a distance of 5. and the opposite side, that rise, is 2. Notice how the sides of that triangle are directly related to the slope that we use. Slope is rise over run, some vertical distance over a horizontal distance. So that's what's represented in this triangle, your horizontal distance and your vertical distance. Let's go ahead and try to figure out the hypotenuse. We can figure out the third missing side. So we would need 2 squared plus negative 5 squared. Let's see, that'd be 4 plus 25. Looks like we'll get the square root of 29. Hypotenuse is never negative, so we'll leave it a positive square root of 29. All right, so they're not particularly asking us for all of the other trig values. They want us to order the values of sine, tangent, and cosecant from least to greatest. So we only need to figure out those 3. You could figure out the other 3, but not necessarily needed for this question. So let's see if we can figure out the sine ratio of our angle beta. What would that look like? Think about SOHCAHTOA for your triangle. Go to Marie, yeah?
Well, we would start off with 2 over square root of 24, and then you would convert that to 2.
Uh-huh.
29, sorry.
It's okay.
Over 20.
There we go. All right, so you initially have opposite over hypotenuse. The hypotenuse is a square root term, so we can get rid of it by multiplying on top and bottom. All right, so there's our sine value. Let's go ahead and try what the next one would be tangent. So think about SOHCAHTOA. What would our tangent ratio look like? Yeah?
2 over negative 5.
All right, so 2 over negative 5, negative 2 over 5. You can put the negative wherever you want in that fraction. There we go. All right, last but not least, we got to figure out cosecant. Cosecant, go ahead, yeah.
It's the same sign.
It's the same as the sine one, just flipped,
Yeah.
right? All right, so we'll have the square root of 29 over 2. All right, so those are the 3 trig values. We want to order them from least to greatest, and we're going to try to do this without a calculator, because I know you could simply just type those in and get a decimal and compare the decimals. We're going to try to think about this in terms of fractions. So of those 3, which one is the smallest fraction value? Yeah? It's negative. Okay, notice how this is the only negative value. That would make it the smallest value. So tangent of beta is the smallest. Then we need the next largest. So we're somewhere stuck between these 2 fractional values. Can we reason through which one might be the smaller of these 2? What do you think, Maddie? Why? Uh-huh.
Well, I said that the square root of 25 is 5. So it would be somewhere around there. And 2 times 5 is 10.
Uh-huh.
And 10 over 29 is less than, say, like 5 over 2.
All right, so you can try to think about a number that's close to that square root. I love it. This is pretty close to 25. The square root of 25 is 5. So this is really close to 10 over 29. If this is really close to 10 over 29, this is really close to 29 over 10, right? Because you flip it, it's the reciprocal. So what would happen here if you were comparing them, notice how this one is the smaller of the 2. So the next smallest would be sine, which means the largest would be cosecant. All right. If you don't like that reciprocal idea, if you use Maddie's same reasoning here, the square root of 29 is close to 25, so this would be close to 5 over 2. Notice how that's about 2.5. This is some decimal value, 10 over 29. All right, so I love it. We ordered it from least to greatest. Perfect. All right, we have one more to do, but we'll check that one out tomorrow, okay? I think we're on a good track.